Hello.
Hello.
Hi, Addie. How are you?
Good. How are you?
I'm also good. We're having a session after such a long time, right?
I
So what you did, like, did you try some test paper or something?
Yes. So I did the practice test 5. So
Mhm.
yeah, that.
And did you check the answers also?
I checked the answers. So I marked which ones I got wrong. I didn't go over them yet because I figured that we would do that together. So
Okay, that's great. So test paper 5, 1 second. All right, so test paper 5, question number. Which one?
this one. Yes.
All right, so which first question? You have done this, right?
Yes. So the first one, I'd starred this one. I got it right, but it was number 11.
All right. Okay, so since you're having the formulas for some cylinders, circle and everything given in the SAT, and there might be some questions which will be related with that formula. So they're telling you the volume of the right circular cylinder. So we're interested in cylinder right now. So right circular cylinder means, it's a straight cylinder.
Right.
It's having a volume of 22 cubic centimeters. And it's telling you what's the volume in cubic centimeters of the right circular cylinder with twice the radius. So, and the half of the height of the cylinder. So what is the formula actually given in the SAT for the volume?
Pi r squared height.
Correct. So it's pi r squared height. Now they're telling you we have to understand the volume of that cylinder, which is having the radius of, which is having twice the radius. So we'll be putting this thing here, pi times twice the radius. Can I write it 2r squared?
Right. Yes.
And height is half. So can I write h over 2?
Yes.
So when I'll be solving it, I'll be getting pi times 2r whole squared. Doesn't that mean it's 4r squared? Because you had to give
Right.
square to both of them.
Yeah.
And then h over 2. So when you'll be simplifying it, it'll be 2 times 1, 2 times 2. When you'll be putting 2 in the front, you'll be again getting pi r squared h. Am I right?
Wait, I'm sorry. Okay. So
Yeah.
you multiplied the 4 pi, or sorry, the 4r squared times the height over 2. Okay, and you got 2r squared and then pi.
Exactly. Right. 2r squared height and pi is there. And then I put the 2 in the front. Is that okay?
Yes.
And this pi r squared, I know it's 22 centimeter squared, centimeter
Yes.
cube. So it's like 2 times 22.
Okay. All right.
40,
That makes
44. Is that clear?
yes.
So that is how you can analyze what could be the new dimension, what could be the new volume, what could be the new surface area if we are changing the radius, if we are changing the height, or else, the volume is directly proportional to the r squared, and volume is directly proportional to height. If you double the radius only, think about it. If you double the radius only, that means the volume will be increased 4 times because the radius squared is proportional to volume.
Yes.
And if you'll double the height only, then the volume will be doubled, simply because it is directly proportional to h, not h squared, right?
Right.
So when they're taking both things into consideration, they're taking they're saying that or the radius is twice, so the effect will be 4 times, and if the height is half, so the effect will be half. So 4 over 2, 2 times 1, 2 times 2. So the new volume will be twice the previous volume, simply.
Yes. Okay, that
Right?
makes sense.
So you can a little bit, make it a little faster by this, by
Okay.
analyzing the variables. What is the relationship with the variables with the volume? Is it directly proportional? Is it like squared? Is it cubed? And so on.
Right. Okay.
Right. All right. So next one.
The one that I had starred was number 12.
Okay. So they are telling you it's just a representation. Since you know that square root of 2 is actually having 2 in outside at the top, right?
Yes.
This means 2 raised to the 1/2. Am I right?
Right. Yes.
And square root of cube root of 2 means 2 raised to the 1/3, right?
Yes.
And in the same way, if you can put 4 also, 4th, root of 2 means 2 raised to the 1/4.
Yes.
And so on. Now here you're having 9 cubed, and that is raised to the 1/4. Am I right?
Yes.
That is raised to the 1/4.
Yep.
So doesn't that mean? But first of all, we'll try to analyze whether we can simplify this thing. We can make this 9 as a smaller number, with some power. Is there any possibility?
Yes, you could rewrite that as 3 squared.
So 3 squared raised to the 3/4. Now, if you're having the power raised to the power, what is the rule?
You multiply the exponents.
Exactly. So somebody's telling whether we are in the class or not. Maybe your mother. I'll be telling her yes. Okay. So so when you're having the power raised to the power, you'll be multiplying the powers. So we'll be multiplying the powers. 2 times 3 over 4. How much is that?
That would be 6/4, 3 to the 6/4.
Yeah, and can you simplify this?
3 to the 3/2.
It's in 3 to the 3/2. 6.
3/2.
Oh, 3 to the 3/2, like this, right? No, 3 to the 3/2 means what?
Like 3 to the 3 over 2 power, or yeah. So then 3 cubed, but then like the square root of all that.
3 to the 3/2. Yeah, okay, I got it. So it's like 2 times 1, 2 times 2, 3 to the 3/2, right? 3 to the 3/2, this thing, right?
Yeah. Yeah.
Okay, so now we're having 2. We can write this as 3 cubed raised to the 1/2.
Right.
Am I right in this?
Yes.
Now,
yes.
Now just the representation. I know that the half representation means square root.
Yes.
And whatever the number is inside, that's 3 cubed. But 3 cubed is nowhere here. But still, I'll be checking what should we do. So this is the answer actually, but the answers are not here like this. So what I'll be doing, I know that 3 cubed can be broken into 3 squared and 3.
Right.
So 3 squared times 3. So I'll be giving square root of both of them with 3 squared and to 3. Am I right?
Yes.
So when you're having square root of like 3 square and root will cancel out. It'll be 3.
3 root 3.
Exactly. With 3 square root of 3.
Okay.
This is the answer.
Yes. Okay, so if I get to that point, I can break that up. I need to remember that.
Yes, exactly. Because when you need to simplify the things, you have to simplify the things according to the answers available. Otherwise, you
Right.
got the answer that was 3 cubed raised to the square root of 3 cubed, but this was not anywhere. So what you
Right.
can do here, you know that the square root can be cancelled by the square term. So square term, 3 squared times 3.
Mhm. Okay, that makes sense.
Hmm.
Okay, so the next one that I had was number 14.
Okay, 14 is here. So we're having some function f of x equals 2 to the x plus 1. So it's 2 to the x, so it'll be increasing, right?
Right.
And there's a y-intercept of 1, right?
Yeah.
Now the thing is, they're telling you the function is defined above here like this, which is the following is a graph of y equals negative f of x in the xy plane. So what we're doing here, we are like doing the, what you can say, first of all, let's try to analyze what could be f of x equals 2 to the x plus 1. What could be, how could that look?
Right. So I mean, I know what that graph looks like. It would be an exponential graph,
Okay, and
and so
where will be the y-intercept?
it would be at 1.
Are you sure? When x is 0, we'll be plotting some points. When x is 0, then
Y would be, it would be 2.
I'll be
Sorry.
2, correct. So I'll be 2. So when x
Mm-hmm.
is 0, I'll be 2. So that means here, this is the point here. And then it'll be going on, it'll be increasing. When x is 1, y will be 3 to the 1 plus, to the 1 plus 1, that's 3. So it'll be like here and so on. So it'll be like this going on up with exponential rise, like, not the linear rise, not the, okay, there are all the options which are exponential. All right, so this is the y f of x equals to the x plus 1. Now the thing which is given here is y equals negative f of x. So we'll be doing the same thing. Negative f of x means what?
That's what I was confused. I didn't know what that meant.
Oh, okay. Um,
I was thinking that it could be maybe flipped over the x-axis, but I didn't think that
yes,
any.
yes, that is what I was also thinking. It might be flipped over x-axis because you're putting, you're doing, what you're doing is you're for the y, whatever the values you're getting, you're flipping that. You're making them negative. Let's
Yeah.
try to understand this thing here. Y equals negative f of x. So if you'll be putting in, so we are having the function as negative f of x. So negative f of x will make it what? Wouldn't that be negative times 2 to the x plus 1?
Yes, it would. So I
So
guess which one? Okay, yeah. So negatives, that would be like -2 to the x power -1.
exactly. So when
Okay.
you'll be putting x equal to 0, which
Um,
option will work?
that would be if x equals 0, that would be -2 to 0. That would be -1.
Negative 1
Or
minus 1, that'll be negative 2, isn't it?
oh, right, because it wouldn't be -1 squared. It would be right. Okay. Or yeah, yes.
Isn't
So it
it?
would be yeah.
So when x is 0, y will be negative 2 to the 1 minus 1. 2 to the 1, sorry, 2 to the 0. 2 to the 0 is 1, so it'll be -1 minus 1, that'll be -2.
Yes.
So the y-intercept in this will be -2.
So that would make it C.
Correct. Is that right?
Okay. I didn't check the correct answer.
Okay, let's check it quickly. So I was having a little bit. What was the number? 14, right? C is correct, yes.
Okay. That makes
So
sense.
this is here, y equals negative times f of x. So negative times f of x means negative times to the x plus 1. And that is -2x minus 1. So we got the 1 point, and now we can even get more points, and it'll be telling us like how is it moving. But we don't need that because we are already eliminating option A, B, and D because they're not having y-intercept as -2.
Yeah.
Isn't
Okay,
it?
that makes
They're
yeah.
not having y-intercept as -2. So
Of -2. Okay. So those were basically all the questions that I had for the inactive
all
section.
right. Okay.
And then for the calculator active portion, the first question that I had was number 18.
Okay. Okay. So is it connected with somewhere?
Yes, with number 16.
Oh, 16 to 18. All right. So you had already understood that there are species of trees and there's a growth factor.
Yes.
And is there a formula which is giving us one method of calculating the approximate age in years of a tree of particular species is to multiply the diameter of the tree in inches by the constant called the growth factor. So that is a formula. So the age of any tree is equal to multiplying the diameter of the tree with the growth factor, correct?
Yes.
All right, so this is the formula. And then 18 is telling us if the white birch tree and pin oak tree each now have a diameter of 1 foot, which of the following will be the close to the difference in inches of the diameters 10 years from now? Okay, so there are two conditions. One condition is that now, what is the condition? And then 10 years from now, isn't it?
Yes.
So now the condition is that they're having both 1 foot as the diameter, correct?
Okay. Yes.
Let's try to use the formula for getting the age.
Okay, so that would be x equals so the diameters for both right now is 1 foot. And it says in inches, so maybe we should do 12. I don't know if that makes,
Let's try to analyze whether we're having the question telling the formula is in inches. One method of calculating the approximate in years of a tree of a particular species is to multiply the diameter of the tree in inches. Yes, exactly. You're right. So that's why we'll be plugging in inches. So
Right.
1 foot means 12 inches multiplied by the growth factor of the white birch tree.
Right. So the white birch tree, if you scroll up, yeah. Okay, so that would be 5. So that'd be 12 times 5, which is 60.
Right. And what was the second one?
It was
Pin oak tree,
yeah.
right? Okay.
So that would be 12 times 3, which is 36. So you have
60 and
36.
pin oak tree. Now 10 years from now, what will be the age of white birch tree?
White birch tree will be 70.
And pin oak tree?
Will be 46.
Okay, so this is the age. Now we have to calculate the difference in the diameters. So we have to calculate the diameters of both of them. So age is given, diameter needs to be calculated, and growth factor we know, right?
Yes.
So 70 is equal to D times growth factor of this was 12, I think.
5.
Oh, sorry, 5. Okay. And 46 equals D times
3.
3. So how much is D of the white birch tree?
That would be 14.
14. So the D of white birch tree is 14. And what is D of the pinnock tree?
That would be,
You can use the calculator also.
yeah, let me just do that. 15.3.
So 15.3 minus 14.
And that's 1.3. So that's how they got C. Okay.
Yes, right. Now clear?
Yes.
So they were just, it was like a little bit confusing because, the age has to be calculated in the first instance now, and then the diameter needs to be calculated in the second instance in the, 10 years from now.
Right. Okay. I think I just need to, like, whenever I see problems like this, if I feel like I have like an immediate solution, I feel like my brain kind of like shuts down. So I just kind of like think it through slowly, I think.
At that time, if you feel that it's like shutting down, then you will not attempt it at that time. You'll come back to it because you had to, do all those questions which you're confident about, like in the first go, which you're
Right.
sure that you'll be doing them in the time, and you'll be doing them in the faster way, and then you'll be coming back to those marked questions where you need more time to solve.
Yes.
For that time you need to like focus more. You need to have, at that time you should say to yourself that now I'm opening my eagle's eye, I'm more focused, I'm so you had to see the question as a whole, and there should be some sixth sense going on, at that time. So then there'll be ways flowing in your brain, like how to do it.
Right. Yeah. Okay.
So what's the next one?
The next one was number 20, which I didn't mark this one as confusing, but I got it wrong. So.
Oh, okay. So 20, there's a figure here on the left, and it shows a wheel with a mark on its rim. Okay, this mark is on the top. The wheel is rolling on the ground at a constant rate. Okay, it's rolling along a straight level path from a starting point to an ending point. All right. The graph of y equals d of t. So y is d of t. Is on the right could represent which of the following is a function of time from when the wheel began to roll. So we have to understand what this really is when the wheel is rolling. So what is this y, and what is this like d of t? Now the height, the y, let's take the height, or the length. The length is at the max here, and then it's reaching 0. And then it's again becoming max, some value, and then it's again reaching 0.
Oh, okay.
So what could this represent? Let's try to read. The speed at which the wheel is rolling. Is the speed up and down?
No.
It's a constant rate. Constant rate means speed is same. So you cannot have speed up and down. So the distance of the wheel from its starting point. So if the starting point is here and the wheel is moving, is the distance continuously increasing, or is it like going up and down?
It's gonna continue increasing. I wasn't, when I did this one, I was just kind of thinking about like that point moving, and I was just thinking about the x-axis, and I wasn't thinking about like how y is going up and down. So yeah, I think I understand now why it's not B.
All right. Okay. So what could be like, what about C?
I think that it's Probably not C because it's going all the way down to 0 and the center of the wheel is never at 0.
Yeah, and the distance of the mark on the rim from the center of the wheel. Center of the wheel and distance of the mark is actually same, it's not changing.
Yes,
So
right.
so distance of the mark on the rim from the ground.
Mm-hmm.
So right now it was highest. Now at some point when the wheel will be moving, it'll be decreasing, 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 and it'll reach to the lowest point, 0, and it'll be again moving and moving and moving. It'll be at the highest point again. So up and down, you know.
Mm-hmm.
So option
Yeah.
D.
Okay, that makes sense.
Okay.
The next one that I had a question about was number 30.
All right.
30. This one I didn't mark as confusing, but I got it wrong. So I don't.
I think I have told you 3 identities.
Yes.
Can you repeat them? Like, can you tell me right now?
Yes. Oh, I think I know it's wrong. Okay. Right. So we know that x plus a times x minus a is
Yeah.
um, x squared minus a squared.
Okay, let's try to use X and Y
Yes.
because this was the basic, otherwise we can use, anything A, B, C, whatever. But we had remembered it in this form.
Uh,
X plus Y times X minus Y is X squared
yeah.
minus Y squared. And
And then x plus y times x plus y is x squared plus 2xy plus y squared.
right?
And then the third one is it x minus y times x minus y?
Yes,
Okay, and that would be x squared minus 2xy plus y squared.
right. And this can be written, the second one can be written as X plus Y whole squared is equal to
Yeah.
this thing. And the third one can be written as X minus Y whole squared is this thing, right?
Yes.
But here we're interested in which one, A, B, or 1, 2, or 3?
In this one we are interested in.
Or else let's try to simplify options A, B, C, and D.
Right. Yeah.
So
I mean,
which
now looking at it, I think that it's B, but I kind of made a silly mistake here. But if we um expand them out, A would be
correct?
x squared
Mm-hmm.
um minus a squared.
Yes, it'll be X squared minus A squared. And that is not the question.
That's not yes. B would be x squared minus a, which we know is right. Um, C would be x squared minus
A over 2 squared, that means A squared over 4.
yes, yeah, a squared over 4. And then D would be x squared plus 2ax plus a squared.
So option D is not the right answer. Option C
Oh,
is not the right answer. It is option B, X squared minus square root of A squared. And that's X squared minus A,
yes. Okay.
right?
Yes.
Or else you could use the strategy. If some student does not remember these things, then we can use a strategy that if you're having a variable in the question and the variable in the answers, make it real. You remember?
Yes.
So how do you make it real? Plug in some value for X and plug in some value for A, and you'll be getting the value of Y, and plugging in same values of X and A in option A, B, C, and D, and checking which one is right.
Right.
That can also be done.
Yes.
Next one.
The next one that I had was number 36.
Okay. All right. So that means we need a little bit info here about the circle, about this geometry. That if you're having a center, and there are some lines which are connecting the center, and exactly on those same points, for example B and C, You are taking again two lines, but they are they are touching the circumference. Then there's a relationship between these two angles.
Right.
If this is x, this will be always and always and always twice x.
Right. Okay.
Because the middle one will always be bigger than the circumference one. So okay. Now so this is one thing which we need to know. So how much would be this in terms of x?
1/2 x.
Exactly, 1/2 x or x over 2. And what is the sum of the angles of the quadrilateral?
360.
360. Isn't any four-sided figure a quadrilateral?
Yes.
So can I say that A, B, B, C, A is a quadrilateral?
Yes.
So can I say that like this is 20 here, this is 20 here, this is x over 2. How much is this fourth angle?
That would be 360 minus x.
Correct, because the total will be 360 for the circle, 360 minus x.
Right.
And what is the sum of all of them?
So 360 minus x plus 40 plus x over 2
is equal to how much?
is equal to 360.
Right. Now we
Yes.
can simplify and get x.
Oh, okay.
Now can you do that?
Right. Okay, so that would be negative negative x over 2 equals negative 40, and then that would be x over 2 equals 40, x equals 80.
So x equals 80. That is the answer.
Right.
Let's check it. X is 80. Yes, x is 80 here. So that is it. Is that clear?
Yes.
So this is the relationship of the two angles, which are, you know, in an arrow. You can remember the arrow. There's a bigger angle here. There's a smaller angle here. There's a bigger angle at the center, smaller angle on the circumference. So the bigger angle is always double the smaller angle in that arrow in the circle.
Okay, got it.
And one more thing, if you're having circle and there is a triangle inscribed in a circle, and that triangle is having one of the sides as a diameter. Okay. The circle is having a triangle, and that triangle is having one of the sides as the diameter. Now, if you'll take any two sides, you know, any two sides, like for example, this and this, it'll be still making an angle of 90 degree. This and this, they'll be still 90 degree. This will still 90 degree. Any angle you make, but one of the sides is a diameter, then this triangle will always make a right angle triangle.
Right. Okay.
Right. So this is very important. This can also sometimes come. There's a triangle here, and they don't tell you that it's a right angle triangle. Then you can say that yes, it is a right angle triangle because one of the sides is is a diameter.
Okay, so if one of the sides is a diameter, it's always going to be a right angle triangle.
Correct. It's always going to be right angle triangle.
Okay.
Always and always. Right?
Yes.
So you have done only this test paper?
This was the one, yes, this is the only one that I did over the week, yeah.
Okay. And can we do some questions which seem to be a little bit harder?
Yes.
Okay. Have you done this thing before? This question?
It looks familiar, but I don't remember what I did, so we can do it now.
Okay. So can try this.
Right. So the equation above shows how a temperature Fahrenheit relates to temperature C degrees measured in Celsius. Based on the equation, which of the following must be true? Okay. So a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 of a degree in Celsius. Okay. Um, okay. A temperature increase of 1 degree in Celsius is equal to a temperature increase of 1.8 degrees Fahrenheit, and then a temperature increase of 5/9 of a degree in Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. Okay.
And we have to
Uh,
check out of the three how many are right.
yes. Okay, so in this case, I think that I would probably just plug in numbers just to make it easier. I don't know if that's the fastest.
Yes, that is what I will also do. That's
Okay.
what I will also do, and I'll make the numbers very simpler. For example, if I want to know one 1 degree increase in the Fahrenheit, then I'll put 32 and 33 because I know that 32 will make it 32 minus 32, it's 0. And then 33 will give me the directly how much is the increase in degree Celsius,
Mhm.
or else you can do something else, like you can put like 10 or 20 or whatever you like. So can you
Yeah.
try it? Can you try it? Yeah, just try it.
Yes. I would probably do like 33 and 34. So
Okay.
33 minus 32 is 1 times 5/9. So that's 5/9 of a degree.
Mm-hmm.
And then 34, that's 2 times 5/9 of a degree. That's another additional 5/9. So
Okay.
that makes statement number 1 true.
Correct. Okay.
Statement number 2, 1 degree Celsius. Okay, so if you have 80 degrees Celsius, um, that would make it okay. So you do like divide that by 5/9, so times 9/5. Hold on, let me pick a smaller number. Um, okay, what if I do like 20 degrees Celsius? 20 times 9/5 is, let me put that in my calculator. Okay, so that's 36 equals Fahrenheit minus 32. So that'll be 36 plus 32 is 68
Okay.
degrees
60.
Fahrenheit.
Mm-hmm.
And then if I did 21 degrees, 21 times 9/5 plus 32. Okay, so that'd be 69.8. So that's a 1.8 degrees Fahrenheit increase. So 2 is good.
And check out the options
And yes, that'd be D.
because we don't have 1, 2, 3, 1, 2, and 3. So we'll not be solving this.
Okay,
That's
so
good.
yes.
That's correct. Next one.
Okay, what is value?
Maybe this might be logging us out. Then we'll be logging in again
Okay, oh yes,
in
that's
2
fine.
minutes. Yeah.
Um, so the equation equals that. True for all values. Okay, what's value A? Um, okay, so I'm just trying to think. Okay, so what I would do is I would basically make everything have a
Mhm.
common denominator, maybe.
Yeah, you can
So
do that.
what I would do is I'd have the negative 8x times ax minus 2. I'm just trying to think if that's sufficient. Yeah, I don't know. Good.
So
Um, Seems like a
So
lot of work.
yeah, this seems to be like that question, like maybe that might take a lot of time. And so in first instance, if you don't get any, any vision, then you will leave this type of question and then you'll come back to it at the end.
Mm-hmm.
But when you'll come back to it at the end, then you had to open your eagle's eye, you had to open your sixth sense, and then you had to see what else can be done here. Am I having any strategy which I can apply here? Am I having any, anything? It is true for all values of x.
Right.
So if it's true for all values of x, why not to make x a number?
Uh,
Because
right.
we don't have to calculate x, we have to calculate a.
Mm-hmm. Okay, that makes sense. Okay. So if you put in like
Let's log
one,
out. Let's log in again.
okay, got it.